off from the radius of gyration. I just understood that certain more derivations should be done. So I'll go through this then. Yeah, derivations. Conceptual basis, solving. So let's get started and grab your books and get started. Moment of inertia plays the same role in rotational motion as mass plays in linear motion. Mass in linear motion, moment of inertia in rotational motion. It is the property of a body due to which it opposes any change in its state of rest or uniform motion. Uniform rotation. Moment of inertia of particle equals to I equals to mr square, mass into the perpendicular distance squared, where r is the perpendicular distance of the particle from rotational axis. Moment of inertia of a body made up of number of particles, discrete distribution, like n number. Moment of inertia of a continuous distribution of mass, treating the element of the mass dm at position r as particle. dr equals to dm r square, I, that is integral of I equals to integral of r square into k. Dimension is ml square t for moment of inertia. SI unit is kg meter per second, not per kg meter second square. Moment of inertia depends on mass. Moment of inertia depends on mass, distribution of mass, and the position of axis of rotation. It depends on mass, distribution of mass, and position of axis of rotation. Moment of inertia does not depend on angular velocity, angular acceleration, torque, angular momentum, and rotational kinetic energy. Does not depend on it. It is not a vector, has direction, clockwise or anti-clockwise. It changes accordingly. It is not to be specified also under scalar quantity either, as it has different values at different positions. Hence, it's actually a tensor quantity. Moment of inertia is what? Tensor. It's a tensor quantity. In case of hollow and solid body of same mass, radius, and shape for a given axis, moment of inertia of hollow body is greater than that for the solid because it depends upon the mass distribution and also the radius. Yeah, so the same thing, radius of gyration of a body about a given axis. A given axis is the perpendicular distance of a point from the axis. Perpendicular distance from the point from the axis, where whole mass of the body were concentrated. The body shall have the same moment of inertia as it has with the actual distribution of mass. Same moment of inertia as it has with the actual distribution of mass. One square of radius gyration is multiplied. I equals to mr square and I by n of root equals to r or k here. So basically the r is given k position. Here k is called the radius of gyration. So what is k? It's the radius of gyration. From the formula of discrete distribution, we can get this. I equals to mnr squared plus m to r square, mr3 square, mrn square, and if m1, m2, m3, m all equals, mass equals, then I equals to m into all the r's together. So from the definition of radius of gyration, we can tell that I equals to mk square. Then by equating first and second equation, it's the very important one. Radius of gyration k equals to root over r1 square plus r2 square plus r3 square. This only modified. This is radius of gyration. r1 square plus r2 square plus of, so n equals to here number of mass. Because mass gets cancelled. Hence the radius of gyration of the body about a given axis is equal to root mean square distance of the consequent particles of the body from given axis. Radius of pf gyration k depends on size of the body. So the radius of gyration depends on size of the body, position and configuration of the Axis of rotation. Distribution of mass of the body with respect to the axis of rotation. Radius of gyration k does not depend on mass of the body. What's not depend on mass of the body but depends upon shape and size and distribution of particular things. ML1T. The dimension is centimeters meter. Significance of radius gyration. Through this concept, a real body, particularly irregular, is replaced by point mass during its rotational motion. Now we have theorem of parallel and perpendicular axis. First and foremostly, theorem of parallel axis. Moment of inertia of a body a given axis 1 is equal to the sum of moment of inertia of the body about an axis parallel to the given axis and passing by the center of the body at given and x greater than m is the mass of the body and is perpendicular to distance between these two axes. Here it is I equals to I equals of ma square. That is of parallel axis theorem formula. Moment of inertia of a body at given axis I is equal to sum of moment of inertia of the body about an axis. Sum of moment of inertia of the body about an axis parallel to given axis. So, I should actually get this thing done. Sometimes it's confusing. The first book I can't hold. Please delete. So let us include first theorem of parallel axis, then theorem of perpendicular axis. So the given statement is as follows. Moment of inertia of a body at given axis I is equal to the sum of moment of inertia of the body about an axis parallel to the given axis, the set, passing through the center of mass of the body, Ig, and ma square, that is product of mass into square of perpendicular distance between two axes or two parallel axes. So moment of inertia of a body at given axis I is equal to the sum the whole theorem. So they will get the formula. I equals to Ig plus NA square. Ig plus NA square. So Ig equals to Ic. That is from center of that is a parallel axis with this theorem of perpendicular axis. Yeah. Example, moment of inertia of a disk about an axis through its center and perpendicular to the plane is half mr square by 2. The next upcoming formula sheet. This is so moment of inertia of the disk about an axis through its tangent and perpendicular to the plane will be I equals to Ig plus mx square. I equals to 1 by 2 mr square plus mr square. Equals to p by 2 mr square. Now we have theorem of perpendicular axis. First understanding, then the theorem. First thing first, according to this theorem, the sum of moment of inertia of a plane lamina about two mutually perpendicular axes lying in its plane is equal to its moment of inertia about an axis perpendicular to the plane of lamina and passing through the point of intersection of first two axes. This side. That's known as according lamina about two mutually perpendicular axes. Lamina's planes. if it's the opposite will be negative value. Ix plus of I by ix equals to I y plus I y equals to z plus I x plus z. It's upon the diagram also. This is x, this is y, and this is z. This theorem is something which is thank goodness just something. Next, I z by x over here x by z like this static. So always difference. Example: moment of inertia of a disk about an axis through its center of mass and perpendicular to its plane is 1 by 2 m square. So if the disk in xy plane, then by the theorem of perpendicular axis xy, I equals to iz, that equals to ix plus I iz equals to mr square by 2. So half mr square is equals to 2 times of height. As disk is symmetrical body, so disk is symmetrical body, so I was iz id equals moment of inertial of this about diameter 1 by 4 mr square. About radius is 1 by 2 mr square. Note, in case of symmetrical two-dimensional bodies of moment of inertia for all axes passing through the center of mass and in the plane of the body will be same. So the two axes in the plane of the body will not be perpendicular to each other. In theorem of perpendicular axis, the point of intersection of the three axes A, x, y, z may be at any point on the plane of the body. Mean will lie outside. This point may or may not be the center of mass of the body. Moment of inertia of 2-point masses both their center of masses at m1 and m2 be two masses distance apart from each other r1 and r2 with the distances of the center of masses for m1 and m2 respectively. Then r1 plus r2 equals to r, m1 plus m1 into m, r1 equals to m2 r2. So r1 equals to m2 by m1 plus m2, r2 equals to m1 by m1 plus m2 into r2. I equals to m1 r1 square plus m2 r2 square. Here I, moment of inertia of the system about an axis passing through the center of mass and perpendicular to the line joining the masses. I equals to m1 m2 by m1 plus m2 to the whole of r square, which equals to mean r square, where mean equals to m1 plus m2 by m1 into m2 by m1 plus m2 is known as the reduced mass, when m1 is greater than mu and m2 is also greater than mu. In diatomic molecules like H2, HCl, etc., moment of inertia about their center of mass is derived from the above formula. So mu value above formula helps in the derivation of these things. inertia continuous body. When the distribution of masses of a system of particles is continuous, the discrete sum I equals to summation of I equals to 1 to n in mi into ri squared is replaced by an integral. We have to sum the contribution of infinitesimal mass elements dm shown in the figure, each which constitutes dr equals to r square dm to the moment of inertia. And the mass element should be chosen such that all particles on it are at the same perpendicular distance from the axis. The moment of inertia of the whole body takes from I equals to integral of r square dm. Keep in mind that here the quantity r is the perpendicular distance to an axis, not the distance to an origin. Perpendicular distance to an axis, not to an origin. To evaluate this integral, we must express m in terms of r. Moment of inertia of rigid body depends on the following three factors: mass of the body, position of axis of rotation, nature of distribution of mass. Mass of the body. Momentum of inertia for rotating rigid bodies independent of its angular velocity. Moment of inertia of a rotating rigid body. Moment of inertia for metallic body depends on its temperature. Examples: if a steel sphere and a wooden sphere have the same mass, the moment of inertia for their diameter is greater for wooden sphere. Therefore, density of iron is greater than that of wood. If a steel sphere and a whole wooden sphere has same radius, the moment of inertia about a diameter is greater for iron sphere because mass of iron sphere is greater than that of the wooden sphere. If a steel sphere and a steel pellet plate has same mass, the moment of inertia of the plate about a normal axis to its center is greater than that of sphere about its diameter. Plate has higher distribution of mass about its axis than sphere. Okay, if we compare moments of inertia of a person rotating about an axis passing through the center of mass with folded hands and stretched hands, the moment of inertia with stretched hand is greater because the distance of the particles of a hand are at greater distance. Moment of inertia for body. Moment of inertia of a body about an axis increases with increasing temperature of increasing temperature of the body. The change in the moment of inertia is given by delta I equals to 2I into delta T and for the linear coefficient of expansion. Moment of inertia is also called as rotational inertia. Moment of inertia itself is also known as rotational inertia. Moment of inertia plays the same role in rotating motion as played by mass in translating motion. That is, if a body has large amount of inertia, it is difficult to start rotation or stop it if rotating. Large moment of inertia also help in keeping the motion uniform. Engines are provided with flywheels having large moment of inertia. Note, the amount of inertia of a thin rod of mass m and length L about an axis passing through center of the rod is ml square by 12. Note, in a similar way, moment of inertia of an annual cylinder about its axis is I equals to m by 2 r2 square plus of r1 square. Torque. If a pivoted or pivoted, hinged or suspended body tends to rotate under the action of force, it is said to be acted upon by torque or the turning effect of force about the axis of rotation. Turning point of force about its axis of rotation called moment of force or torque. Moment of force or torque due to the force. The particle rotating in xy plane about the origin under the effect of force F bar and retaining its same position with pair of particle R bar there. Torque equals to R bar into F bar. So modulus equals to R into F sin theta. Where theta is the angle between the rotation of R bar and F bar. Torque is axial vector, that is the direction is always perpendicular to the plane containing vector. explain figure, the sense of rotation is if r equals to x, inward is negative, outward is positive, and the shoes which you're wearing has some socks. Yep. Based on that we have talk here, and the torque has certain components, and component is the regular components of force. Then under the sections are components of force. So we have certain examples, that is, thus the magnitude of torque is given by the product of transverse component of force and its perpendicular distance from the axis of rotation. But this torque is due to transverse component of force only. A is equal to eta, not eta, through equals to F sin theta. R bar equals to F sin R sin theta, which equals to F D is R sin theta from the figure. Torque equals to force into perpendicular distance. Torque is also added as moment of force and something. It's called moment and maximum and minimum torque. Maximum and minimum torque has torque of F bar plus F into something else. Torque of R bar equals to R bar into F bar, then R F sin theta. A, E, F, H, H, or phi, or drop torque by 92. Max is going to take the minimum is going to be max minimum. For a given force and angle, magnitude of torque depends on R. The holes. The holes depend on the formation of the secondary structures formed on the stem leaf after the apparent layer heat exit. The particle rotating slightly above the origin under the coefficient of friction. Force F bar and at my instant the position vector of P is P. If the particle rotating in xy plane above the origin made under the effect of force F bar, and at my instant the position vector of the particle is bar. Torque equals to R into F, which equals to torque modulus, which equals to R F sin theta. Rational of analogous momentum, this is angular momentum, radius rotational analog of momentum. Rotational analog of momentum equals to angular momentum. Rotational analog of a system equals to angular momentum. And torque is an axial vector, that is, its directions always perpendicular to the plane containing vectors I bar and F bar in accordance with rigid hand screw rule. For the given figure, the sense of rotation is anti-clockwise, so the direction torque is perpendicular to the plane outward, so the exasperation. So for a given angular magnitude, torque depends on the more the value of the more will be the torque and it's easier to given force in angle magnitude 5 Florida given for a given form torque depends on mostly more exams will get done. Okay. Then examples handles are provided near the free edge of the flank of the door. The handle screwdriver should be thick. In villages, handle of floor mills placed near the circumstance. Double hand of the land pump is kept on. The arm pump wrench used to open for tap pump is kept along. Unit equals to Newton meter SI and 9 centimeters. So dimension is m1 square t minus 2. If a body is acted upon by more than one force, then the force torque is the vector sum of torques which do not do anything to each other. F bar rho bar equals to rho 1 plus rho 2 plus rho 3. Rho 1 that is not a body is said to be acted upon by one or more than one forces. Example, handles are provided near the free edge of the plank of the door. The handle screw of the driver should be thick. In villages, handle of thermal is placed near the circumference. The handle of hand pump is kept along. The arm of wrench is used for opening. The tap is kept along. Newton is Newton meter and it is kg. Kg meter cube. Newton meter. And time system is the body is said to be introduced with gravitational equilibrium only if Fr modulus equals to F cos theta equals to the radial component of force x-axis anti-logwise. Then the rectangular components of force as R bar equals to R into F sin theta or torque equals to radius into F naught equals to position vector into transverse component force. Thus, the magnitude of torque is given by the product of magnitude of torque is given by the product of transverse component of force and is perpendicular to the distance from the rotation, that is torque is to transfer component forcefully only. Transfer component forcefully only. As torque equals to R into sin theta. Torque equals to force into displacement. Distance of line of action of force from the axis of rotation. given a force. Dimension from the moment of force is vector while work is scalar. The moment of force or torque is a vector quantity. Torque due to torque due to many forces acting at different points on rigid body. There are not position vector of points of application. Mechanical equilibrium of a rigid body. A rigid body is said to be mechanical equilibrium. Force exerting Newton at lower temperature are not changing than or equal. Body has neither linear acceleration nor angular acceleration. Condition for translational equilibrium. Well, that was all for today's study session. I will be back after a small break again. So hope you all studied also. Yeah, catch up with you soon. Till then, revise once and yeah, bye. Conditions for translation.